Hey everyone, welcome to our webinar today. My name is Joey Wilson. I am one of the hosts, along with Deirdre, who's running the back end of it. And I'm going to pass it over to Nicole shortly, but welcome to our webinar. I work for CS for All Teachers, which is a part of the American Institutes for Research, and we're excited to have all of you here to learn about exploring computer science in Scratch, getting students computationally thinking. And throughout this webinar, if you have questions, please feel free to put them in the chat box, and I will try to make sure that I get those questions to everyone, or you can raise your hand and via the service, and I will unmute you if we have some time, if there's a break in the conversation. But with that, I'm going to pass it off to Nicole, and hope you all have a great webinar.
Good evening. This is so exciting to see so many teachers on a school night joining us. I'm super excited to be talking about computational thinking and Scratch. Tonight, we're going to be hearing from some amazing folks. Besides myself, we've got Nancy and Eric Schilling who are joining us. I am a teacher from Salt Lake City, Utah. I have been teaching computer science for a little over 5 years. My background is that I was a German and business teacher, and 1 year I got voluntold I'd be getting to do computer science in the fall. So I got all wrapped up with programming and getting ready for computer science, and I've been teaching it for about 5 years. I get to teach exploring computer science as well as the new AP computer science principles. One of my other fun things that I get to do is be an ambassador for the CS All community. As our panelists tonight, we have Nancy Steve. She is a PD and PLC Coordinator as well as a former high school teacher in South LA. She taught ECS amongst other things, as well as Eric Schilling, who is a Scratch Learning resource producer. And so I'm going to let them take over and share with you some amazing things tonight, and I'm really excited to hear from them.
Awesome. Thank you, Nicole. Hi, everybody. It's me, Nancy. And Eric, you're on the line?
Yep, I'm here. Yep.
I just switched the slides. Did everybody see that?
Yep, it looks good to me.
Okay, great. Well, I think we wanted to start this evening with talking about what computational thinking is and why a lot of you, several of you labeled or identified as being a novice, and I think I saw one or maybe two of you in there consider yourself an expert. So please enter the chat or unmute yourself and chime in whenever you hear something that you might want to add to what Eric and I are saying about computational thinking. So first we wanted to talk about why it's important, and so we get into some of the definitions and the research of computational thinking, and then after that we wanted to talk about the applications in both our work. So with Eric at Scratch and with myself teaching ECS, I think a lot of you are ECS teachers. Eric, did you want to start about why you might think computational thinking is important?
Yeah, can everyone hear me? Hopefully folks can. Yeah, okay, great. Thanks, Sean. Also really good to be here. Sorry, I'm making sure that my mic is muted when others are talking, so sorry to be a bit delayed there. Thanks, Nancy, for the intro. Yeah, so it's really exciting to sort of be talking about computational thinking with fellow educators. I think one thing that we talk a lot about in the research group that I am a part of, the Lifelong Kindergarten group, we talk a lot about computational thinking as a way in which you can not only sort of be using these concepts when you're literally creating a computer program, but also just some of the problem solving that happens when you are, thinking creatively about how it is you want to find a solution to whatever question it is you're trying to solve. And I think we see a lot of that in computational thinking, is like how can we think about the steps to accomplish something. And that takes, in a lot of ways, creative thinking. So creative thinking, thinking creatively, is part of that. And I think in computational thinking, there's a lot around collaboration. And so, so often the code that we're using, the programs that we're building, are being built on remix from code from other folks. And you can also say that a lot of the programs that are being built now are teams coming together, doing pull requests, and it's really a collaborative project, and it's front end, back end, and so I think this notion also of working collaboratively is really important. And then finally, I think sort of reasoning systematically. So when you try to debug and you're tinkering, you're sort of like backtracking and making mistakes and iterating, and so I think that's really true in computational thinking, and it kind of extends beyond just when you're making a project or when you're coding. So it's the notion of thinking creatively, reasoning systematically, and working collaboratively. I think those extend to so many different disciplines in the classroom. And so and just to add, and then I'll stop rambling, is I think computational thinking, it allows you to sort of express and bring to life your ideas. And I think Nancy and I will talk a bit about that later. But I mean, it's a great sort of tool and way of thinking to try to bring that idea that you have in your mind, bring that to life. And so I think those are two sort of reasons why I think computational thinking is quite important. So I'm going to stop rambling. Nancy, I know that you have thoughts.
I do. I loved everything that you said, and I absolutely agree with it for sure. And I wish that as a teacher that just like getting kids in the classroom and learning and playing and tinkering is something that I would love to do, but from like a more practical standpoint, where not only are we as teachers held accountable, but our students are held accountable for what they're learning and how they're learning. I do think about what computational thinking is and why it's important in the classroom from an added perspective from all the things that you just said, which were all wonderful. So, for example, I'm often in my classroom thinking about what is it that I have to help our students learn so that they are able to be productive citizens in our society. And even now, I have friends that are doing jobs and have titles that I never heard of growing up. And so I can only imagine what those jobs and those titles are in the future. And the only thing that I feel like is guaranteed is that they're going to need a lot of these skills that this school of computational thinking really does a good job of describing. And so I think what Eric and I are going to get into next is what that definition of computational thinking is. But just to add to why I think it's important, I recently, they want me to start my webcam. Do you guys want to see my face? Here it is. That's weird. Can I not share my face? Okay. Anyway, so what was I going to say? So I don't know if you're all aware of who John Ma is, but John Ma is the CEO of Alibaba, which is like a very similar company to Amazon. And so one thing that I heard him say in a talk very recently was how education has to be transformed. And the reason it has to be transformed is because of all the advances in technology right now. That, you know, there's this fear of automation and job automations and machines taking over jobs. And so what does that leave us with, and what does that mean for students and teachers? What are we supposed to learn? And I think John Ma said something very beautiful where he said, well, education has to transform into something that robots cannot do. So what is it that robots cannot do? Robots cannot collaborate with other people, which is why it's an important aspect in computational thinking. Robots cannot think creatively. They can't like draw and do art. And so when we think about how we want to teach it, I think computational thinking is a really good guide for us in that work to transform from a knowledge-based education into a more transformative one, where students are doing all of the things that Eric was describing earlier, remixing, working with other people, making things. And so I think that's why it's important. And there's a lot of policy now that that also values it's important in education, and it's just the beginning. And then so what can we all be doing together to learn more about computational thinking and to also share best practices with each other. So I feel like this is a really exciting time, and I'm glad you're all here. This is a lot more like me giving and Eric giving than I'm used to. So if anybody wants to say anything, please, I guess, raise your hand or enter something in the general chat so it could be a little more interactive. But if you don't, then I'm going to assume that you're all enjoying listening to me and Eric ramble. Let's talk about what computational thinking is for some of you that didn't label yourself as experts. I wanted to give you all a summary of Roxana Haddad's work. So she is a researcher out in UCLA, and she put together a presentation that put the research and the work of studying computational thinking in order, which I use as my compass when I'm thinking about computational thinking and its application in my classroom. And so it seems like it started with Wing's research in 2006, and Wing defined computational thinking as a way to provide problem-solving techniques for addressing our modern problems across all fields. Wing talks about how it builds on the power and understanding the limits of computing processes to solve those problems. And then a few years later, Wing et al. Continued that research, and they defined computational thinking as the thought processes involved in formulating problems and their solutions, so the solutions are represented in a form that can effectively be carried out by an information processing agent. And so the thought processes and the information processing agent, that had to be unpacked. And so there's more researchers that continue to add to this conversation. And we get to Karen Brennan, which I think Eric's a huge fan of. So I'll let Eric, you talk about how Karen Brennan defines computational thinking.
I guess. I think I have looked to some of the work from Scratch Ed and Karen Brennan, and that's also built on the work of Mitch Resnick and others around computational thinking. It is tough. So when I saw this first question, I was like, God, how would I define computational thinking? Because it's really tough to define. And I thought Karen Brennan and Scratch Ed have a very thoughtful way of approaching it and that question. And if you're not familiar, it's kind of broken up into three sort of sections. And the first is concepts, which I think sorry, there might be a bit of an echo. Sorry if there's an echo. The first is concepts, and I think folks are probably familiar with this, which would be, so you have the idea of conditionals. So in computational thinking, if then, that's obviously that's part of computational thinking, and events. What triggers a script, and so that's one part of computational thinking, certainly understanding those concepts. But then I think the practices are something that I am really really dig into and interested in my work that I've done with the Scratch online community, which I had spent 3 years as sort of the director of the online community, which is, what does Scratch allow young people to do, and what does sort of computational thinking allow for? And that is this idea, and Nancy touched on this earlier, of like experimenting and iterating. So you develop a bit, you develop something, you try it out a bit, and then you develop it more, and it's kind of a spiral. And I think that's really fundamental, and a fundamental practice of computational thinking, and this notion of like let's remix a project and reuse some code. That's another practice of computational thinking. And again, that extends beyond just like computer science. You can, many disciplines be using that. And so you have concepts and practices, and then again, like this is highlighted in the Scratch on the community, is what Karen and Scratch Ed calls perspectives. And you could use whatever sort of whatever word you want there, but this is about sort of the expression piece. And so, what's so powerful about code and computational thinking is this ability to then better express the ideas that you are a creator. So no longer you're just consuming the application that's given to you or the social network, but you're now in the driver's seat and you're creating this content. And it also allows you to connect with other people who are sharing their ideas. And it also allows you to then sort of question and sort of expand your thinking and knowledge. And so I think that's a really holistic way of looking at computational thinking. And in a lot of the work that we do at Scratch, we keep all of these things in mind when we're developing resources and when we're doing initiatives in the online community. And so I thought that was a nice way to frame computational thinking. And later on, we'll make sure, Nancy and I will make sure to share with you, there's actually a website in which you can go to, and it's outlined pretty nicely, these three kind of pillars, if you will, of computational thinking. And so that's, I think, been fundamental to me over these many years that I've been sort of thinking about this. I totally lost my window there. Okay, I think I'm back, but I don't know. Yeah.
No, it sounds great. So I think we'll move on to the next part now, which I think will probably be more engaging for all of you to listen to, is now how might educators facilitate computational thinking in their classroom? And so I actually got to know Eric at a Scratch conference in Ohio. I flew out to Ohio for a hip-hop and Scratch conference, and it was there that it opened my eyes to Scratch in a way that I'd never seen it before. So I've been teaching ECS for the last 5 years, and so I'd been teaching Scratch for 4 years before I had gone to this conference in Ohio. And so, and Eric, you can add to the definition, but it was bringing in hip-hop culture and teaching students how to program. So one of our projects was for everybody to create a music video in Scratch, and so that's where I learned how to make use the wand tool and put myself in a music video. And it was actually one of the best lessons that the kids got to do. So it was really cool to go to. Yes, I can share the video. It's a video of me dancing with Drake, and Kanye pops up randomly. So it gave me some street cred with my students, but it was also really fun to just like get them out of their seats and get them into the hall so they could take poses and then program that. So I'm talking about just like making stuff in the classroom. And so having this lesson was a really fun opportunity to do that. But one thing that I walked away from the conference realizing about Scratch is Scratch is aptly named. So like DJ scratching, like that, I think that was one of the intentions for why it's called Scratch. Remixing, and so like that, there's a reason why you can remix someone's project, because like Eric was saying, we want students to be producers and not just consumers, but a lot of producers now, they're remixing from other people and taking something and making it new. And if we're talking education speak, that's a level 4 depth of knowledge, DOK 4, applying, synthesizing information. And so what we'd like to go into now is more of, I guess, what I learned from Eric and the Scratch team when I was in New York about some of the abilities in Scratch that you all might not maybe are aware of firsthand. Like there were some purple and blue blocks that I'd always ignored before, but in having to make this music video, I used it, and it was really fun. Also, like I think Eric, you'll get into it, but all of the educators there, from both the informal and formal spaces, we all put our music videos on a studio. And so there are all these little things that I learned from Eric and the team that then I was able to bring into my own classroom. And so I think we wanted to impart a little bit of that into this community.
I'll probably if we want
Eric,
to go back to
you can talk a little bit about Scratch and some of the cool things that you love about Scratch, and then I'll jump in and talk about how
I wanted to sort of take an opportunity just to show you briefly, quickly, just some resources that you might want to think about bringing into your classroom, and also talk a bit about the Scratch Online community and how we see sort of the computational thinking concepts flourishing, and just give some examples of that. And so actually, if I could share my screen, am I sharing my screen? Okay, great. I'm going to share my screen here, and we're going to, if I'm currently sharing, okay, how are we doing? You can probably see the Scratch website. Yeah. And so let me just, so can one of the presenters let me know if that's true, because I can't see anything else. Can you see my screen? Okay, great. Okay, cool. Thanks, friends. And so I wanted to sort of take an opportunity to, I think, show you on the tips page. So if you're on Scratch and you're looking for, and you might already know this, but
yep, we can see your screen.
There's on the tips page, we have around 11 activities wherein you can find resources to help you present an activity and run an activity with your students. And not only can you get a tutorial that they can follow in the Scratch editor, but we also have cards and guides here. So if we click this, we see animate your name, we'll click see cards and guides. And I want to point you to the educator guide. And the educator guide here will help step you through how it is you might set up that hour, how you might set up the classroom, how you might create an icebreaker or like an introduction activity to generate ideas. And I'm really proud of these resources because I think they speak to this expression piece. So all of these activities really do allow you to break off from the tutorial and sort of infuse your own ideas. So in Make It Fly, we suggest you draw your own character. In Make Music, we suggest you record your voice. In Animate Your Name, we suggest you use any word. And so there's a lot of entryways out. And I think that's really important when we develop resources here on Scratch, is making sure that students have sort of the agency to be creating and expressing their own idea, their own twist on the tutorial. And so I think what you'll find in a lot of these activities is they are very suitable for a classroom that has very diverse interests. So if you have the kids that are more into making games, there's plenty of games here, but there's also animations and stories that you can create too. So I would point you this direction. And I want to also, I think, step back and talk more directly about computational thinking as it plays out in Scratch, and two really quick examples of projects that I think exemplify young people exhibiting sort of this is computational thinking. And so I want to share with you this project. If you're not familiar, this is an MAP project, which stands for Multi-Animator Project. And this is essentially young people in the Scratch community collaborating to produce a longer animated project. And so in this case, the user Amy Laser had the idea that they wanted to create a music video for one of their favorite songs, Viva La Vida. And what they've done is they reached out to the Scratch community and asked folks if they can contribute a small portion of animation that's linked to a certain part of the song. And you can see here, I'll zoom in a bit. These are all the animators that participated. So you can see there's around 22 folks who contributed animations, but also they put a call out. They put a call out for people to contribute audio and sounds. And so it just kind of shows, I'll just show quickly just 30 seconds of this. It shows sort of what happens when you invite folks to collaborate and you allow them to be working on projects that are like meaningful to them, and creating this platform and just sort of seeing what happens. And so here's just 30 seconds.
I used to rule the world. Once surprised when I gave. Now in the morning I sleep alone.
Okay, the audio quality might not be great, but I think it was important for me to show because I think it really speaks to this idea of, kids are eager to collaborate with one another, and what you see in the Scratch community is projects around every single interest you can imagine, and it's really important for us in the Scratch community. And I would think in classroom too, is to allow kids to be creating and sharing around these projects that really are of interest to them, and letting them set up their own collaborations. And so, I don't know, those are two examples, the tips page and sort of checking out the online community and thinking about collaborative projects. I think those are ways in which if you tomorrow wanted to start thinking about implementing that in a classroom, I think that would be good. Okay, I'm going to stop sharing my screen.
Yeah, to add to that, I learned a lot from the existing resources that the Scratch team, that Eric's team put together, and I'd modify things and make things that were more pertinent to my own classroom. So the micro worlds you see, what I do is I do something similar where so I teach at a gaming school, and so I needed them to make a guess the number game. And so what I would do is I would pull out some of the blocks and I'd write some comments for some tips, and then I'd send out that link, and then the students would remix that. And so instead of just giving them like a blank canvas, they got something that looked very similar to a micro world, but I was able to create my own by doing that. So I learned a lot from what Scratch has already done to teach students computational thinking in their own classroom, and I would just model things after that. So like the cards that Eric was talking about, that was really cool because the first time that I'd been introduced to those tutorial cards were at the conference in Ohio, and it was cool because it was non-linear. Like you didn't need to do this step and then this step. It was just kind of like pieces of code, and then you had to just put them together in however you wanted to. And so I really liked that concept because one thing that I'm striving for in my own classroom is for students to be autonomous, but also for them to recognize that I don't own knowledge, that it does come from them. And so I try really hard to prevent situations where students are asking me permission for something. So I like to put resources on their table already, and they can just grab it when they want to. Like, so for example, in scaffolding, let's say the guess the number was really difficult for a student, then I'll have like a resource card that really walks them through it. But instead of having them ask me for that extra help, it was already on the table for them, and they got to choose whether or not they wanted that additional resource. And it was really cool to see some of the students challenge themselves and not looking at that. So it's like if you're playing a video game, like a cheat code that they tried, so that's what I called it in jargon with the gaming school, a cheat code. And a lot of them were just like, no, I'm not going to look at the cheat code. I'm going to try to figure this out on my own, which lends itself to what Eric was talking about, Karen Brennan's third dimension of computational thinking, the perspective that students need to take. So when I think about the perspective that they need to take, it's the attitudes that they should embody. And one of the attitudes they should embody is like a tolerance for ambiguity, confidence in complex problems. And so in presenting it in that game-like manner, but also really creating agency in them, I think that that was one of the ways I was able to implement some of the research findings into my own classroom. And so I wanted to thank you all to, and I think some of you who are in my PLC right now, you've already seen this, but I don't think you've seen this edited version. In the chat box, I just sent you a link to Fizzbuzz. Yeah, there you go. So go out and check these different microworlds and see if you can use it in your own classroom. And like I said, once you get a feel of the microworlds and the tutorial cards, make your own. So I made my own through Fizzbuzz. So for those of you who are not familiar with it, it's a common whiteboard problem for technical interviews. So if you were to go apply to like Snapchat or Facebook, and they'd have you do like a technical interview, they'd have you do a whiteboard problem. Fizzbuzz was one of those that was pretty common. So I encourage all of you in any time you might have, I know it's scarce, to try it out. But those are some of the ways that I was able to learn from what Scratch was doing, but also how Scratch was more open than I had realized, and that's how I was using it in exploring computer science, particularly to teach computational thinking. So I think with that, we can finally stop talking and open it up to other people. I guess if you are interested in asking a question, you can maybe either raise your hand. I think there's an icon, or you can put your name in the general chat, and then we'll call on you and you can unmute yourself, whatever way works. I think, Nicole, you want to moderate the Q&A?
This is Joey. While people are putting their questions in, Nancy, you mentioned something about tolerance for ambiguity, and I think that that's a really interesting topic. And so I'd love if you could talk a little bit more about how that relates to computational thinking.
Yeah, so I think maybe like 5 years ago, this is when I first started at the Critical Designing and Gaming School, and all the rage back then was this idea of failure and learning through failure. And I happened to teach in South LA, and so for me and a lot of my colleagues, it was really hard and jarring for us to hear that we're supposed to be comfortable in failure, that we're supposed to be that failure was a positive thing. And I think for me anyway, it was just like an issue with the nuance in language, because growing up, failure wasn't an option. For many people, and especially for the students in our community, failure could be fatal. And so I really wanted to think about, well, what is it that we're really trying to say about failure? Because I do agree, I don't want students to feel devastated when something doesn't work out for them. And so Roxana Haddad, who I mentioned earlier, who studies at UCLA, she, in her research, and I don't think it was her research, I think it was somebody else, and I'm not sure who to credit right now, but they came up with a list of attitudes that support computational thinking. So confidence in dealing with complexity, persistence in working with difficult problems, tolerance for ambiguity, the ability to deal with open-ended problems, and communication with others. And I think that's important in computational thinking because we don't know. I mean, I grew up with like AOL Instant Messenger, and now I have Facebook Messenger, and I mean, those things kind of happened in a way where, you know, as easily as I took a breath today, those changes happened, but we really don't know what problems are going to face our kids, our students, and the problems that they have to deal with, and in many ways they're going to have to deal with not knowing. And I think it's maybe like a brain metabolism thing where in order for our species to survive, we're going to have to be tolerant of ambiguity and have the courage to keep going and keep thinking. Because those problems now are just things that we can't prepare for.
Great. Thank you,
Nancy, we do have a
Sean,
question that just came in.
Go ahead, Nicole.
From Sean. So go ahead, Sean.
No,
Well,
that was
looks
me.
like
I was just
Sean-
going to read it.
Okay. Oh, go ahead.
So Sean Patrick Higgins wrote, I was wondering about how Scratch fits into ECS Unit 4 and what your experiences have been with it. I've been doing work with Scratch with middle school for a bit, but we want to help our new high school ECS teacher next year.
So what I've done with the Scratch unit is came up with a big project called Computing for the Social Good. And so that was like the first big project, and then the second big project in the unit was a game fair. And so in order to prepare students for the, it was a public service announcement that they had to animate in Scratch, and for a game, for the game fair, we had to teach them how to do various things in Scratch. Like, so first they learned how to move, and then after they learned how to move, they learned how to use the event blocks. After they learned the event blocks, they learned how to use the control blocks, so how to write a conditional statement and so on and so forth. And so in giving them little projects and learning those different targets, they were able to create two big projects. And like Eric and I have been emphasizing, it's being able to put our students in the role of producing, and not just producing, but giving them an audience. So it was really beneficial for our students to then take whatever they made and display it outside of the classroom. So other students saw it, other teachers saw it, parents saw it. We brought people from industry in to check out some of the presentations. And so that's how I was able to use Unit 4 for any school that's crazy about interdisciplinary projects. ECS definitely lends itself really well to that. And so that's how I was able to use that unit of ECS at school.
I have a question for Eric and for Nancy. And one thing that was just mentioned in that question is if you've had students use Scratch in middle school, what are some great ways that you can engage students in understanding the complexities of Scratch and it still being appropriate at the high school level?
That's a tough question. I do understand. Yeah, we talk about Scratch a lot, about the low floor,
Eric,
so it should be easy to get started, and it should be, you know, that so newcomers don't feel intimidated. But there is an interest in this, the idea of the high ceiling and sort of doing things that are more complex. And so I think remixing content is a really powerful way to sort of get at some of the complexities. I think connecting to the physical world, if you have the opportunity to use video sensing, if you have the opportunity to hook up to a Makey Makey, or I'd point you to Scratch X, I think that's one way in which you can use Scratch to sort of get at that question of how it is you create like more complex projects, and that could become attractive to folks that are a bit older. I'm not sure if that answers the question, but that's one thing is I think I spend a lot of time kind of shying away from some of the complexities of Scratch because we focus so much on this low floor to make sure that folks aren't feeling intimidated. And with Scratch 3.0 that we're developing now, there's a lot of questions around, like what new things are we going to add? And, I'm happy to say that like we've kept the floor really low.
I can say from my own personal experience that, middle to high school, that even within just one grade level of the ninth graders that I teach in South LA, that they also need differentiation. There are some kids that were like ready to do this and some kids that had never touched the computer before and knew how to operate a mouse. And so I think your question is similar to the answer that I would give around differentiation. So it depends on the question you ask. Scratch is just a tool, and it's the teacher's responsibility to come up with the questions. And Scratch, like I was saying, is ready to serve the teacher. And so, for example, for some kids, it was hard for them to come up with like a click game. So get a bunch of items on the screen, have those items move around randomly, and when you click on the item, it disappears and it gives you a point. So that was like a level 1 kind of game that some students had to start with. And then there were some students that did that level 1 game really quickly, and then they had the challenge of, okay, so now do a platform game. So now here's your problem, right? Do a platform game. So what's a platform game? It's like you've got this element here, you've got to like make this other, so basically you have a lot of sprites interacting with each other. And how can you program those sprites to interact with each other? Right, when this does this happens. And so it's in the questions that you ask the students that they're gonna have to think of the solutions to these complex problems. And I think that Scratch is great because it has the ability to attract everybody. So Eric talked about having that floor, and I don't think a lot of people talk about the ceiling, but I think if you like check out the Fizzbuzz, problem that I came up with, you might have a different perspective on what that ceiling in Scratch might look like or could look like.
Thank you. We've got about 15 minutes left. I'd like to go to the next slide on reflection. And as you've talked about computational thinking, Eric mentioned kind of the 3 pillars. And I think that ties in that depth and complexity that you can add to Scratch. When you just focus on those surface level concepts and you don't ever get into the practices and perspectives, a lot of times students don't understand all that planning and thought that goes into the project and then the reflection afterwards and that collaboration, getting people's ideas. So I don't know if if Nancy, you and Eric want to talk about our next slide that we have on the reflection piece.
Yeah, I mean, I think like Eric and I are not the only experts here. We want to hear from all of you too. So how do you currently facilitate computational thinking in your classrooms? And I guess just for Eric and I, what might be some takeaway from today that you plan on bringing back to your classroom? Because I think both as like so I'm a trainer for ECS and Eric community, what may be some takeaways?
Oh, I was just going to, yeah, I'd be interested to hear some of
similarity.
the reflections. I mean, I've been
Just
taking
like,
away a
I
lot
guess,
of
raise your
sort of
hand or tap.
what's been said because I've been so focused on like the online community has kind of served as like the de facto classroom for
Eric,
me.
did you want to finish your
It's been really
sentence?
interesting to hear sort of your reflections, Nancy's and others, on how it is you're using computational thinking. Yeah. Oh, I see. Sean's mentioning showing high ceiling stuff, following some of the very fancy game makers on Scratch. So I do I do think it's good to be showing aspirational projects on Scratch. However, I would caution that then becomes the objective and the goal, and so to two things. One, in the Scratch community, the featured projects that you see on the homepage there, we curate that row to show off a variety of genre and sort of expertise, if you will, from Scratchers. And because we want you to sort of land on Scratch and understand that within this community, as creators, there's a varying level of expertise and genres. And so we make sure that we don't always highlight some of the more complex projects. And I think that's one thing, is also sort of sets expectations. And so I would, it's good to show those, but also I would be cautious on the examples you show that are very complex, because I think there's a lot to be gained from showing simple games and celebrating in a group the small victories. But I do love Griffith games and Kevin 11 games, so I feel you, Sean, but just a word of caution.
Yeah, I want to add to that, Eric, because I think it's really important that when you think about math and science, there are a lot of students that identify that they are bad at math and science. And one thing about computer science is it's been such a novelty in our classrooms that I have students that should be afraid of computer science but aren't afraid of computer science because they don't see how complex that it can get. And so I agree with Eric in that caution. So, you know, it really is about getting to know your students and how would you engage them. Maybe for some students, seeing that where they can get to could be really helpful for them, but for some other students, it might be too intimidating where they might not start. And so I agree with that.
Looks like we've got some resources down here. Scratch resources, Harvard CS50 are some other ones that people have put in. So it's great to have you enter these in, because we can always add them to like the blog after the webinar, where we can kind of share a resources page. So hearing this is super awesome. So please keep those coming in for another couple minutes. Looks like David asks, how do we all keep in touch together? We do have some resources that we have on the next couple of slides on how to stay connected, but that's really important as we think about some of the things that have been shared tonight. This is the first year I'm teaching computer science principles, and some of the projects the students are doing have shapes in them. And a lot of my students didn't understand what the angle was to create a triangle, and they would spend 10, 15 minutes just trying to create the right angle. And so as Nancy mentioned, you have to do scaffolding activities where they have that agency to go choose what kind of scaffolding do they need. They have kind of like different envelopes they can get things out of that gives them more tips and tricks, so that they're not spending the entire class day trying to just make a triangle. So I think that's important to focus on knowing the needs of your students
really quickly,
and then provide that.
I'll put a plug in. If you're on the Scratch community and as far as scaffolding, I would suggest searching the term engine. And a lot of folks have been producing projects that have some like base code that is really useful if you want to create a variety of projects. So for instance, if you're interested in scrolling background, you might find a scrolling background engine, which gives you some of that base code that you can build off of. So you might not get stuck on trying to build it from scratch, and you might be inspired and try to understand the logic behind their code, and that gives you like a real launching off point. And there's a variety of engines out there, from platform games to text generators to scrolling background. So to Nicole's point about scaffolding, that's one thing that you might think to start with is that kind of project. Sorry, Nancy. Okay, cool. Yeah, so I wanted to mention the computational thinking in Scratch. I've been quoting Karen all night. If you follow that link, you'll see the website around computational thinking that has outlined, I guess we're calling them like pillars, the three sort of aspects of computational thinking, and also some resources such as the Scratch Curriculum Guide, which is a very useful document that helps you set up a 6-week sort of class wherein you are creating Scratch projects and sort of thinking about, infusing computational thinking into the classroom, and you have a design journal, which offers the opportunity to reflect back, which is super important. And then Nancy, actually, I will call on you. Do you want to talk about the resources for computing and for social good?
Yeah, I talked about the two big projects that we do in Unit 4 of Scratch, and the first one is a public service announcement based on a social problem that the students picked. And so in a group of 4, they come up with a problem, they research it, they do various things in their other 9th grade classes, but in my class, they synthesize their learnings in a story, and they create a PSA. And so in that Google folder, I think this is a Google folder from a CSTA presentation that I gave on computing for the social good in ECS, and so a lot of documents are there. I think like worksheets, examples,
and then I think the final resources we wanted to share
and so
is the Learning Creative Learning online course.
Do some project-based learning with Scratch and ECS,
and the Learning
I
Initiative
think
at
that
the Media
folder
Lab.
has some resources
It's just run, though it's still
with.
live. You can check out the resources, and we dig into creative learning, and it's a lot about the new book from Mitch Resnick called Life on Kindergarten, and it talks about projects, peers, passion, play. We touch on Scratch, and so I highly suggest checking it out. We're actually going to run the course again starting in February. It's going to actually coincide with a live version of the course that's taking place at the MIT Media Lab. So I would totally suggest checking that out. It's all free.
I highly recommend it. I loved it. I loved it. It really added to just what I want to do in my class and what I hope students are doing too. So I highly recommend it.
Awesome. These resources look amazing. So the other request that people had is how do we stay together as a community?
Yeah, so Scratch Ed is a network of educators who are using Scratch that's run out of the Harvard Ed School. I think Sean is a part of that, and you can go online and you can access a number of resources that are organized very nicely. And so this is all sort of community is sharing these resources, so they're all available free. And also within Scratch Ed, you are invited to host a local meetup, a Scratch Ed meetup, where educators who are using Scratch will meet every other weekend and share what it is they're doing. And so there's more information on how you might want to host one, and also information on ones that might be happening near you. So I think that's a really great resource. And then I am totally biased in saying this, but the Scratch community I think is a wonderful resource for a lot of the reasons that I mentioned earlier. So I would highly suggest checking it out. And we are going to be launching the new version of Scratch 3.0. In the coming months, you'll see a public offering of that, so definitely stay tuned for that. Of course, yeah.
Well, these communities are fantastic. And then I assume you also have Twitter handles and other resources that we can eventually share with people if they want to connect with you and ask you one-on-one questions.
My Twitter handle.
Yeah, if you want to stick those in the general chat, that'd be awesome. And then Joey from AAR, if you want to tell us about some of the upcoming activities, that would be awesome.
Sure thing. So on Tuesday, February 13th, we're going to be having, basically the same time here, another webinar about virtual reality and augmented reality in the classroom and how to connect that to some computer science concepts and beyond. It's meant to be not experts that are doing this, but teachers who are implementing this. So it's people who are on the ground who are trying this out and seeing, what's working and what isn't. And if you have any additional thoughts about webinars that you'd like to see related to exploring computer science, related to Scratch, related to other topics, you can also email us at csforallteachers@aar.org or go to our website that Nicole mentioned, Nicole also is a teacher ambassador, and she runs the ECS Open Group. You can go to csforallteachers.org. Our Twitter handle is csforall. Teachers spelled TCHRS because it's the internet and we abbreviate things. And I'm trying to think, is there anything else? Oh, yes. Before you, when you close out of the webinar, there's going to be a survey that pops up. It'll take about 2 minutes. We'd love to have your feedback on this webinar and what you thought about it, so that we can constantly improve what we're doing and how we do it, so that we can support you and the rest of the computer science education community. Is there anything else from everyone else on the call?
Well, I would love to thank Nancy and Eric for planning their evening with us and sharing some great resources and hearing from you all as teachers. I know on a school night when you've got papers to grade and lessons to plan, that coming to a community like this is super powerful to get you recharged and to get some new ideas to connect with your students so that you can help them be more successful in their computational thinking. So thank you so much for joining us, Nancy and Eric. And I assume that you're going to be getting a lot of folks connecting with you, so we'll keep you super busy.
Thank you.
Great, and we'll have the recording up on the website. We'll tweet about it, so if you have any colleagues or friends who weren't able to make it, we've got this recorded, and we'll make sure to update our blog with